Welcome in the subject Engineering Materials and Metallurgy. So today we will learn the important topic of Engineering Materials and Metallurgy, which is crystal imperfections. So we know each and every material is formed by a crystallographic structure or a definite arrangement of the crystal, and if there is any kind of irregularity or a dislocation or a defect, the imperfection occurs in the crystal. So we know the crystal is a solid which is made up of a combination of atomic arrangement or molecules. So crystal is a solid which is composed of atoms or molecules. So each and every crystal structure is formed by a arrangement of the atoms or molecules. So in crystal, it is a solid where the atoms arrange in some definite pattern, okay, or the molecules arrange in some definite pattern. Then atoms or atomic arrangement or molecular arrangement is repeated in 3 dimensions. So that is also called as a crystal. Then the atomic arrangement is a regular and continuous throughout the crystal. That is also important thing. Then all materials having number of defects. That is also one important parameter. Then defect in a structure plays an important role in the selection and use of the material. Means there should be a deformation in the form of defect so that the material can be utilized for a particular engineering application. Then next point is the classification of crystal imperfection. We know if there is a defect present in the material or if there is a irregularity in the crystal or dislocation in the crystal, we can call it as a crystal imperfection. So there are 3 types of crystal imperfection occurs. First is a point defect, second one is a line defect, and third one is a surface defect. So depending on the type of defect, the crystal imperfection is classified into 3 categories. One is a point defect, second is a line defect, and third one is a surface defect. Now, what do you mean by point defect? So if there is a imperfect packing of atoms during crystallization, then the defect occur is called as a point defect. Means during the formation of the crystalline structure, if imperfect packing of atom is occurred during the crystallization or crystal formation, the defect is called as a point defect. So first point defect is a vacancy defect. Second point defect is an interstitial defect. And third point defect is a substitutional defect. Fourth point defect is a Frankel defect. And fifth point defect is a Scotchy defect. So these are the various types of the point defects which shows the imperfect packing of atom during crystallization process. Vacancy defect, interstitial defect, substitutional defect, Frankel defect, Scotchy defect. So what is vacancy defect? So if one or more atoms are missing in a crystal, such defect is called as a vacancy defect. If one or more atoms are missing in the crystal structure or arrangement or in the atomic arrangement, the defect is called as a vacancy defect. That is nothing but an absence of atoms in the crystal structure. So what is the reason behind it? Why the atoms are absent? Because due to the thermal vibration of atoms at high temperature. So in material, if there is a thermal vibration of atoms at high temperature, the one or more atoms can be missed, and such defect is called as a vacancy defect. So in this image, you can observe that number of atoms are arranged here, and here you can observe one of the atom is missing or molecule is missing. So such type of defect is called as a vacancy defect. So the atoms are arranged in a definite manner, and if one or more atoms are missed from its position due to the thermal vibration of atom at high temperature, the defect is called as a point defect. So this is again one example of vacancy defect. So here in this image, you can observe there is no defect. There is a presence of all the atoms in a definite manner. And in second image, you can observe there is some atoms are missed from this place. Or here also the atoms are missed. So the defect occurs called as a vacancy defect, which is a point defect. Second defect in the point defect is the interstitial defect. So whenever there is an entry of extra atoms and which occupies the interstitial position in the atomic structure, such defect is called as an interstitial defect. So without distorting the parent atom, the defect is called as a interstitial defect. So you can observe this is the atomic structure arranged in the space, and there is some interstitial positions, so or void space. At that void space, if any one atom is entry occupy the interstitial position, such defect is called as a interstitial defect. So you can observe this is the example of my interstitial defect microscopic image. So here you can observe this is the definite atomic arrangement, and some of the external atoms are in take the position of the interstitial sites. So the defect due to that also defect occurs called as an interstitial defect. Next one is substitutional defects. So whenever foreign atom occupy a position at a atomic structure, such a defect is called as a substitutional defect. So the original atom is replaced by another foreign atom. So here you can observe in the example or atomic structure, this atom is considered as a foreign atom which occupies the position of the initial atoms. So due to that also the defect occurs in the crystal structure called as a substitutional defect. This is also example of Frankel defect. Next, missing atoms occupy interstitial position, means in the atomic structure the atoms changes its position and take the position of the interstitial sites. So these are the interstitial sites. So this atom originally is at this position and it will change or move from this position to another interstitial sites. So due to that, what happened here, there is a missing of the atom, and here there is a extra entry of the atom inside the interstitial space. So this type of defect is called as a Frankel defect, means missing atom occupies the interstitial position. Next defect is a Scotchy defect. So the pair of positive and negative ions, if it is missing from the crystal structure, then such defect is called as a Scotchy defect. So the cations and anions are there in the crystal structure, that is a positive and negative ions, and if these ions are missed from the pair, from the crystal in the pair, such type of defect is called as a Scotchy defect. So here one positive atom is missing and a second negative ion is missing. So such type of defect is called as a Scotchy defect. You can also see the examples of Frankel defect and Scotchy defects. So here it will take the miss from this position and take this position. That defect is called as a Frankel defect. So the atom miss from its original position and take the interstitial site or position. Such defect is called as a interstitial Frankel defect. Second one is Scotchy defect. If here you can observe one anion is absent and here cation is absent. So if the anion and cations are absent in a pair, due to that also defect occurs. Such defect is called as a Scotchy defect. Now, what happened due to that defect or point defect? These defect may hamper following properties of the material. So that will affect on the yield strength of the material, fracture strength of the material, plasticity of the material, thermal conductivity of the material, and dielectric strength of the material. Okay, so that is the effect of defect or point defect on the properties of the material. So yield strength, Frankel strength, plasticity, thermal conductivity, dielectric strength, these properties are going to change because of the point defect. So that was the first type of defect. Second defect is a line defect. In that first defect is the edge dislocation. So the half plane of atom is included in plane of atom in a perfect crystal. Such defect is called as the edge dislocation. So here you can observe one example. So this is a perfect crystal, and if there is a missing of atom in a plane or in X and Y direction, due to that what happened? The crystal is going to dislocate. So this type of dislocation is called as a line defect, which is a edge dislocation. This is also one of the example of edge dislocation. A dislocation of half plane you can observe here. So whenever the half plane is slide or slip with respect to a in particular direction, the dislocation occur is called as a edge dislocation. So this is also one of the good example of edge dislocation. So here is the arrangement of the seeds inside the product. So here you can observe there is a dislocation in the crystal structure. So such type of example is a edge dislocation or line defect. Means in a line or particular plane, the atoms are missing or dislocated from its original position. Such type of defect is called as a edge dislocation. Second dislocation is a skew dislocation. Whenever atoms are dislocated in two separate planes perpendicular to each other, such a dislocation is called as a skew dislocation. So this is a perfect crystalline structure without defect. And second one, if the atoms are dislocated in two separate planes, so here one plane and here second plane. If such type of defect A and B and this plane is a C plane. So if the atoms are dislocated in two separate planes perpendicular to each other, such defect is called as a skew dislocation. This is also example for the skew dislocation. So arrangement of atoms appears like skew or helical surface. That's why this location is called as a skew dislocation. So here you can observe the dislocation due to application of this force. And here also you can observe the dislocation in perpendicular direction. Okay, so such type of dislocation is called as a skew dislocation. This is also one of the example of skew dislocation. Then the difference between edge dislocation and skew dislocation. So one of the atom is absent or replaced as an extra atom. Such a dislocation is an edge dislocation. And atoms are displaced in two separate planes perpendicular to each other. Such a dislocation is a skew dislocation. Then defect is represented by this symbol perpendicular. Then in a skew dislocation, defect appears as a screw or helical type. Then in edge dislocation, defect is located on one of the edge of the 3D structure. In skew dislocation, spiral distortion beyond the unit structure is observed. Then third defect in crystal imperfection is a surface defect. So defect that takes place on the surface of the material is called as a surface defect. The defect that takes place on the surface of the material is called as a surface defect. In that, first defect is a grain boundary, second defect is a twin boundary, third defect is a stacking fault, fourth defect is a volume defect, fifth defect is the planar defect, and sixth defect is the low angle boundary defect. Now, what is meant by grain boundary defect? So grains of different orientation of atoms with boundary takes place when liquids gets into the solid. So such type of defect is called as a surface defects. Means whenever there is a formation of solid from the liquid at the grain boundary region, the defect occurs or irregularity occurs. Such type of defect is called as a grain boundary defects. So in this image, you can observe that the grains are arranged with the help of grain boundary during the solidification from liquid to solid formation. At this region, there is a dislocation or some kind of defect is present. Such defect is called as a grain boundary defect, which is present on the surface of the material. That's why it is called as a surface defect. So here you can observe in this diagram, see here at grain boundary, the defect is occurs. Here also defect occurs. Here also you can observe the defect. Then here also defective region is shown. So if the defect occurs according to the grain boundary during the formation of solid from the liquid, the defect is called as a grain boundary defect. Second one is a twin boundary defect. So boundaries in which arrangement of atom on one side is mirror image of atoms on another side. Such defect is called as a twin defect. So here you can observe in this image or example, this is a part 1 of the image, then this is a part 2nd of the image, and this is a part 3rd of the image. So whenever there is a mirror image of this part 1 and part 2nd with respect to the twin planes, such defect is called as a twin boundary defects. So here this region shows the twin boundary defect. This is also another example of twin boundary defect. The boundaries in which arrangement of atoms on one side is a mirror image of atoms on the another side. So here this type of defect is a twin boundary defect. Next defect is a stacking fault. So stacking of atoms is not in proper sequence. Means if the arrangement of atoms is not in the proper sequence, such type of defect is called as a stacking defect. So here you can observe in diagram A, there is some definite arrangement of the atoms. So there is no any kind of fault present. In diagram B, so here sequence of the stacking of atom is changes. That's why there is an irregularity observed in the structure. So this type of irregularity, here also you can observe the irregularity. This type of fault or defect is called as a stacking fault or stacking defect, which is a surface defect. Next one is a volume defect. So voids or local region featuring different phases. Voids, large number of atoms missing from a lattice, that is also called as a volume defect, occurs in the crystalline material. So this type of effect is occurs in the crystalline material. Means if large number of atoms are missing from the crystal and it will form the void space or empty spaces, that is also one kind of a dislocation or defect. Such defect is called as a volume defect. Next defect is a planar defect. So boundaries between the perfect crystalline region and its surrounding, if there is a defect, such defect is called as a planar defect. So here you can observe this is a part number 1, part number 2, and part number 3. So these 3 parts are joined by a boundary, and if there is some kind of misalignment in that boundary. Such a type of defect is called as a planar defect. So here you can observe the planar defect. Here some region you can observe the planar defect. Here also planar defect means boundary between perfect crystalline region and its surrounding. If there is some kind of defect, that defect is called as a planar defect. Next one is a low angle defect. So if there is angular misorientation between the grains, such type of defect is also called as a low angle boundary defect. So here you can observe in this diagram, here theta is the angle which shows the tilt of the atomic arrangement. So here or grain arrangement. So here you can observe some misalignment in the atomic arrangement. Here also some misalignment of the atomic arrangement. Here also some misalignment of the atomic arrangement. So this is called as a low angle boundary defect. So this is all about the various types of defects, that is a point defect, line defect and surface defect. Due to this kind of defect, the imperfection in the crystal occurs.